All right, next slide. All right, so occupancy-based controls. Why? Because we have to now, but considerable energy savings over the schedule-based, reduced greenhouse gas, KWH, KW, reduced customer complaints. It's good for the space with flexible or variable occupancy, which is perfect for me on schools. The challenges. Occupancy-based HVAC is not common yet. It should be, but it's not. It's difficult to cross those silos to integrate controls in different systems, and you got to resolve a lot of zone issues. Why? About, well understood, widely implemented, required in Title 24. Sensors are ubiquitous and available. So all of that stuff's out there. We should be doing it. Opportunities. Make the HVAC occupancy-based like the lighting. Currently, there's lots of systems. We can turn the lights on and off, adjust them to the right levels, the right color, whatever we want. But we also need to be able to do that with the HVAC now. We can use the available sensors instead of redundant ones, hopefully. We can unify the reporting and controls through Bacnet. Everything we bring it into Bacnet, building automation system, and one place. Next. So we're going to talk about one particular building that we just got done doing that I'm really excited about the results on. This is our main administration building. It also houses our police station, our IT server room and department, president, the vice president, the provost. It's got a couple lecture halls. It was built in 2002, and it's much better now. Next slide. We talk about the basis of design for controls. Some of the things that we think about are the lighting has to communicate with the HVAC system. The sub-meters need to be brought into the building automation system. We have to be able to control the individual light levels and the HVAC in every individual office for maximum comfort and productivity. I've already seen, when we start putting in the lights and making it tunable to the individual users, people get really happy. In the past, we would do lighting retrofits and you would set them to whatever you thought was best, and not everybody likes what's best. How did we do it? Slowly work on creating a campus standard. It didn't happen overnight. I started playing with this in about 2014 to getting to finally this year, I'm able to do entire buildings and tie it all in. I would do one classroom at a time if that's what it took back in the day. You have to get the mechanical design engineer to buy into your vision. So we built 2 new buildings this last couple years, and I had to sit down with them and explain to them what are the benefits, show them where the lead points are, show them how we're going to be able to control things better, how it's not as complicated. Depending on the system you use, it's actually cheaper to install labor-wise than some of the other stuff. Next slide, please. So some of you will recognize this. We went with the Enlighted control system. This is one floor of the 4-story building that I was telling you about, and you can see every one of these little green dots is a sensor and a light fixture. We were able to go in and adjust everybody's offices. Some people wanted different light levels on the 3 different fixtures in their office. The one over their head was one level, and the one by the window, or the one by the door was something else. Next slide, please. So that took care of the lights. That was easy, right? We could adjust the lights. Now we tie it into the HVAC. That's the most exciting part for me. So if you look, you can see a bunch of square blocks. In a sense, that's a VAV zone. The VAV is the valve that opens and closes to let air into the individual spaces. In a perfect world, everybody gets their own VAV. In the real world, classrooms get their own VAV and presidents and vice presidents, but office people have to share a VAV with 3, 4, 5, sometimes 6 offices share one zone. And so when we control that space on the HVAC, we're pretty much setting a schedule from 7 in the morning until 10 at night. Now, with the lighting controls, we know if somebody's in the space or not, and we can group that into one control point that says, hey, all the lights in these 4 offices are off, nobody's in there, turn off the VAV. But then we have to figure out how do we bring that into the building automation system. So let's go to the next slide. So there's 2 screenshots here. The one on the left is they're the same. The one on the right is sorted, but depending on what building automation system you have, we use a Metasys at our campus, but all of the newer stuff should work. It's as simple as doing a device search. I'm not a control specialist, and I was able to figure this out. We do a Bacnet device search. The system goes out there, scours a network, and finds every Bacnet point. You see at the top, it has these CSU, DH, NCIS, and blah, blah, blah. Those are the enlighted points if the zone is on or off. Then we have a couple of electric meters, and demons. Then we have some more lights, more meters, shark meters, sensors, that kind of stuff. Once it's brought into this view, you've pretty much brought it into your building automation system. It then is a point just like any other point, just like a thermostat, just like a pressure sensor, temperature, it doesn't matter. And any good facilities control specialist should be able to program to that point. So let's go to the next slide. So here we've gone and programmed all those points. If you look down at the bottom right, it says total count is 56. This is a summary screen of the 4th floor, all the VAVs on the 4th floor. So there are 56 different thermostats or VAVs on that floor. If you look in the middle where it says damper position, the first 16 are above 0, meaning all the zeros that you can't see all of them are because the damper position is at 0 because nobody is in the space. And so this is critical now with COVID because that building is only 30% occupied maybe. And by doing this, we're able to shut down the air conditioning or the supply air to all those spaces. And then the most exciting screen, next please. So this is, we talk about bringing your energy data into it so that you can see everything. This building has electric meters on it. So this is a sub meter for just this building. This is from January to now, or June, the beginning. And you can see in the beginning here, in January, we did the LED retrofit with the smart controls on it. And so we were working around at nighttime, so our energy load went up a little bit. We were also not that populated the first couple weeks of January because of the winter break. Things ramped up. And as the lights went in, the power density started going down and down and down. And then you look at the first red line, that line is March 17th when COVID hit and the stay-at-home order went to everybody that wasn't an essential employee. At that point, we had the enlighted and the LED. We had the light levels set, most of them to 40% or less, and the occupancy was working. So you can see that we dropped down, doesn't look like a lot, but it's significant if you were to draw a line across the top of the middle there all the way to the left. Then in April, facilities control specialists figured it out and got the lights brought into the Metasys building automation system, and the power density just dropped. And if I had more time, we'd have another slide that shows this month. It's still dropped even a little bit lower than that. So the top is our KWH, how much electricity we're buying. The middle is our KW demand, which is going to be important when we add batteries to this building and solar. And the bottom shows our fan speed, because that's what happened. When we were able to tie the lights into the building automation system, the static pressure dropped way down, the fan speeds were able to turn way down. In the beginning, we were having issues tuning it and commissioning it, and you see at the far right, it just got nice and stable, and it stays that way now.